How do you find the limits of some well-known functions? For the following three functions, f of x equals c, g of x equals cx, h of x equals c times e to the power of x. The limit at a point is the same as the output at that point. Using the method we have seen so far, you find the limit for an input, a, by seeing what number the outputs tend towards for values close to a. This can be quite tedious. Let's look at a few more examples, and in the process, discover a few rules. Start by looking at f of x equals 1. This is quite nice to reason out. You want to find the limit at some point a. Take a point near a, like this, and you get 1. Now take a point closer than the last point, say half the distance. What do you get? 1. Again. No matter how close the point is to a, you get the same output, 1. In other words, the limit of f as x goes to a is 1. So, we have a new rule. The limit of f of x is 1 at any point. Notice this is the same as the output of the function at any point. In fact, the general rule is, for any constant function f of x equals c, the limit at any point is c. Now consider the function g of x equals 2 times x. The graph looks like this. Let's take an arbitrary input a. This time, if you go slightly away from the point, you don't get the same value, but using the graph, we can see what happens as the input gets closer to a. Consider this input, indicated by this blue dot, with this output, shown by this red dot, starting to the right of a. As the input gets closer to a, you see the associated output always gets closer to the output 2 times a. The same thing happens if you start on the left, so the limit as x goes to a is 2 times a. The general rule here is, for any function of the form g of x equals c times x, the limit at any point a is c times a. Finally, let's consider the function h of x equals e to the power of 3x. Let's consider our arbitrary point a, draw the graph, and do the same as before. Start from the right. You see that as the input gets closer to a, the pink dot on the graph goes towards the output, e to the power of 3a. Doing the same from the left, the input approaches a, and it still gets closer to e to the power of 3a again. So, the limit as x goes to a is e to the power of 3a. This final general rule is, for any function of the form h of x equals e to the power of cx, the limit at any point a is e to the power of ca. At a later point, you will see those functions with this property that the limit at each point is the same as the output are so important that they have a special title. They are called continuous functions. For the following three functions, f of x equals c, g of x equals cx, h of x equals c times e to the power of x. The limit at a point is the same as the output at that point.